Good morning, everybody. Audio check.
Yes, we hear you.
Thank you.
Good morning.
Good morning.
I missed last week's meeting. Did you guys have a chance to talk about that table?
Mac, we did talk about it, but we didn't come to any conclusions. So I don't know if you missed anything. And obviously you weren't here, and I had raised a couple of questions that we discussed. So
Okay, thank you.
Hi, everyone. Thanks for joining the meeting today. I think we have is Bijan here yet? Because he made a couple of updates from about the outlines. I'm still on my way to a stable place for sharing. So I'm wondering if Ron, can you share the file, and then maybe we can start discussion until Bijan unable to join the meeting. Ron?
Hey, sorry, Bobby, I was on mute. Sorry, what was the question?
No, can you help sharing the outline? I think Bijan add a couple of the comments and editing, and maybe we can sort of discuss in here.
Okay, give me a minute to pull that up.
Sure, yeah. Hi, Siamek. If you can send me the title of your speak and the abstract, that would be great. I need to put that on the schedule website.
Okay.
Thank you.
How much time do I have for that?
Hopefully, it's pretty late now, so I would say as soon as possible.
No. What I meant was, how many minutes do I have for?
Right now, I'm assuming it's about 15 minutes.
Okay, that's good. Thanks.
Yeah.
All right, give me a second here. I'll share my screen.
Thanks.
Okay. Oops. This is what you're looking for, Bobby.
Yeah, I think Bijan, Bijan's here.
Yeah, sorry, a little few minutes late, had Wi-Fi.
Great. So Ron was able to put up the the things that you edited yesterday, and I think it's a good time that we can kind of go over it a bit.
Sure.
Okay. Yep.
Yeah,
Go
it's
ahead,
definitely not.
Bijan. Yep.
Okay, yeah, it's not gonna take the whole half hour. What I, I think what we talked about last week, was making, um, was kind of like reshaping this a little bit to have it be more action oriented and to have more tangible outcomes. So that's kind of what I tried to do here. I reformatted the outline, mostly. I have a lot of, data and information and content and things like that, ideas, but I, when I first started doing this, I put all that in and it just became more confusing. So I took it all out
Mhm. Okay.
and decided, hey, let's work on the shape of this first. And then once we kind of, come into some, agreement on what the shape of this is, then we can kind of fill in some, go into the minutia and add details or whatever. So here you could see what I tried to do with the first section was kind of just say, let's just be explicit about what our problem statement is. And I didn't really make any changes as far as the overview notes that are listed there, but I do think we need to have a very strong problem statement to start this document. And oh yeah, I forgot. I also added some notes in the margins there. So let me go to my copy of this so I can reach. So yeah, so I had goals when we started this document of um, listing all of the stakeholders that are, probably, facing all these issues. So hyperscalers, the vendors, the, ASIC GPU vendors, network guys, photonic startups, all those guys, plus all the, SDOs like OIF and IEEE, UEC, UA Link, and so on. And I see all those stakeholders as kind of wanting the same kind of guidance. They all want to have, you know, a very a more clear direction. So that's who we're talking to as far as what I can see. Um, the other, so there's layers to this. The other layer to this is I think we need to develop a system level view instead of just a kind of a technology level view. So I think that, while we're all, here on this call, we all have some network expertise. I think that, if you put yourselves in the shoes of the end users of this, the people that would benefit the most, then I think you need to be looking at this at a system level and how all these things kind of interact with each other and what the requirements are. So I put in the margins some of my ideas, like, there's nothing earth shattering here. This is just, in fact, kind of mirrors some of the data that's already in this paper so far. But, like latency, bandwidth, energy efficiency. um, and then, we have kind of another layer on this, the modularity. And with the modularity, then you have kind of requirements for interoperability. And so, at that layer, everyone's hearing all these acronyms all the time, CPO, mid-plane, CPX. And so how can we, kind of sort out like what is the, where does everything fit? Because obviously you can't just say, hey, it's one way only, right? The reality is there's multiple, kind of interests in the market and there's multiple ways to get there. And if anything, we see that the market is kind of like lightning, right? It'll try branching in all these different directions until it finds its true path to ground. So I think that we have to be, open with all of this potentials, but we have to be at the same time list the guardrails. Like what is the interoperability requirement between all of these things for them to fit into a system? And then lastly, is kind of just obvious, but how do we deploy it? What economic requirements can we set for it? If something is hard to do, let's say it's free space optics, then the yield on that will be very low as you deploy it. So you can't just put everything in here. You have to have some sort of like methodology for selecting things and down selecting things. So adding this kind of economic and deployment advice will help us shape this whole document and come out with a real outcome. I'll pause there in case there's any questions. Actually, would it help if I shared the screen?
Sure. Go ahead, Bijan. And I was just going to comment that, yeah, I think that is super helpful. We do need to keep the end user in mind, with all of this. And so maybe having sort of framing the problem statement that way. I'm definitely open to your ideas on how to maybe revise this.
The topics, of course, are very important, and perhaps the first section of the overview or such, we will need to describe these things in text and paragraphs and such. But at some point, we should have that table that we talked about a couple of weeks ago as well as summary. A number of parameters that Bijan just talked about are important. We need to describe them, and each one requires a sentence or paragraph. But at the end, it would be also good to have a table, because that will be a form to compare, contrast, map, allocate, all of that as well.
I think I got you covered. I think our table, I made a reference to it. I agree with you.
Very good. Thanks.
All right. I don't know why I am.
Yeah, Bijan, I think I give you the grant the share assets, so you should be able to share now.
Oh, I have to change. Shoot. Yeah, I may not be able to do this. Zoom. Yeah, I mean, I'm sorry. I have to allow it in the settings and
All the Mac things.
yeah. So yeah. So you should share it. Sorry. I can't get there from here without a reboot probably.
Okay, I can go back to sharing.
Sorry. All right. If you scroll down to the second section,
Yeah.
so there I kind of decided so for the section topic, I kind of decided to let's drill it down, and so instead of just immediately answering the question, how can optical helps link, I thought maybe it'd be best if we defined what interconnect requirements are.
Okay.
And so part of the table that CMAC was referencing could be developed here. Part of that table could be, just the blind requirements as far as, if you have, and that could be first principles. It could be built on like, if you intercept this type of HBM or this type of, IO, this type of these are then here are some requirements, or it could be more kind of synthetic where you have this link type is going to be of type this much bytes, and so on. So but the point is that in this section I was thinking that we would actually kind of do a lot of the work. this is where a lot of the work takes place, is setting up like what are the requirements, and I think that a lot of people have made some really good had already put some very good points in here, so I didn't remove any of those points. I think we can incorporate this information into this, as long as we view it as what's driving the interconnect requirements. But I think that this, in my mind, it kind of made it easier for me to understand where we were headed next, Um, and I reformatted. If you keep going down a little bit, sorry, I'm mobile today, flipping
Into
back and forth.
section 3 or
No, a little bit before that. A little bit before that. Yeah, right about
right
there.
here?
So, yeah.
Okay.
So the section C was a different, topic, and I felt like, that really was kind of a summary of what the section should be. So I collapsed it and kind of put it in there. Like I said, it really is good. If you look in terms of what the interface requirements are, and we're answering questions like what is the radix requirement, what is the reach requirement, for example, what Kathy had put there or Karen had put there, um, you, what is the reliability fit rate, whatever it is that we
Mhm.
have to define as a requirement. I think that's a really good place to put it. It was really well put. So I just kind of made it fit.
I agree with you completely. That was exactly what I ran into when I started to write this section, is that in order to discuss radix, I had to explain why radix limits the network size, right? So then that's not really appropriate for just listing the radix, right? It kind of, you had to have all that explanation from the top down to begin with. And then there was a suggestion to have a metric in terms of operations, right? And it was like, well, but what's the linkage between the network and your tops, right, per watt or whatever, right? And that was missing, right? So I concur with you exactly.
I'm hearing all the good points that you guys are making, but Bijan challenged us to think about systems and customers. So thinking of that way, this section I think is wonderful for listing the parameters of import. The values for individual parameters, we probably should discuss them later. At the beginning, we say, okay, people are worried about bit error rate. They're worried about radix for these reasons, all the reasons that you guys say. But a particular number for the number of ports or how far these things are or a particular bit error rate at this section might not be a good time yet, because from the customer point of view, you say, what kind of bit error rate do you want? 0. How far do you want to go? Very far. What the energy should be? 0. So this is what they want, but that's not necessarily available. So,
Right.
and then based on and then what they want, and then I think you guys are describing it. There are different use cases. Sometimes things are close, sometimes things are very far. So these are all the high-level things. Later, we can describe what people are in fact doing, what's available, what the different companies are targeting different use cases, and they have perfected their solution for that. Maybe we can say what is available. Different companies or different technologies have a range of parameters for power and distance and bit error rate and such and such. Later, maybe a finer version at the end would say, okay, based on what people want, based on what people are doing, based on what physics allow us, then these are guidance. Requirement is kind of maybe hard to say, but these are what will be useful for people to purchase or do things.
Yeah, so let me switch gears back to our we talked about tables. So here was our original table where we had, I think, most everything that was on that previous sheet. We need to cross-reference this, but our goal all along has been to describe these requirements. We've listed some of them here. And the point being that the requirements show where short reach optics is viable. So what our guidance needs to be is to help the industry define or help the industry understand that if a particular technology meets these requirements, it's going to be viable. The answer can't be zero in terms of power. The answer has to be something realistic, but something that's commercially viable.
Hey, Ron,
And so,
I think this is 100% right, and to kind of incorporate both of the viewpoints, CMAC and yours. I think that we should relook at this table and maybe adjust it a little bit and
yeah,
not consider like what the state of the art is or what like what is the bandwidth based on the Blackwell throughput, but let's say what's the bandwidth requirement for HBM memory, for example, or coherent memory or whatever it is. So we should definitely look at it from the perspective of what the customer wants and what the system should have. So I think you're right, all the data's here. I think it just needs to be kind of maybe tweaked or maybe looked at in a different light.
yeah. The reason I wanted to pull this up is I think we're focusing on the rows and getting the each of the accurate information for the requirements for each row. The columns is where I think we need to revise. So the columns, as you see, are a little bit too broad and generic. I think when we're starting to talk about scale up and scale out, maybe we can collapse these. So what are folks' thoughts on collapsing this to either a single column or at the most two
Um,
columns?
so is Ryan here? Ryan did a collaboration on, because we have the chapter 4, and he did some thoughts about reform the table. Ryan, do you want to share the tables that you sent it
Is this
to me?
potentially? No, I don't think so.
Sorry, are you calling Brian or?
Ryan. I'm calling you.
Okay. Yeah, my table really is more listing the possible, at least the optics, different various type of optics discussed. I can show that, but I think I'd like to make a comment, just follow up earlier discussion about system. I think at the end of the day, reliability, cost, all these things really need to look at from a holistic system level, because like you said, reliability can be zero fit, cost can be zero either. So I think this will be a good opportunity to actually really reframe the economic side. Like, are we building a bigger system can help customer, to generate more tokens per second, a token per watts, or can we have much more quicker response and serving more customer on inferencing? So I think it would be nice to actually have a more holistic view of what's driving the decisions, right? Because if you say I only need to build one rack, I think copper clearly going to win. But if you can build, 8 racks of system, you can actually provide better economics to customer, then that's when optics really need it, right? So I think if we can frame that way, reliability also become reasonable system parameter to look at. Like if you build a 1,000 GPU system versus build a 100 GPU system, that reliability is different because the link number can go dramatically up when you build a much larger clusters, right? The other thing also important is we tend to only focus on optics, but I've heard people saying, hey, you have to be as reliable as copper. I think that's just a non-starter, right? You can't really start from that. I think the key point here is there's just so many elements in the system can fail. What is the reasonable optics not become the bottleneck? I think that's important, right? For example, GPU can fail. If GPU already fails, so what's the point even have optics more reliable, right? So I think we probably should have industry inputs on that as well as part of this white paper, so we can really properly frame these numbers like cost and reliabilities. other than just focus on a single component and say, here is a requirement. Does that make sense?
Okay,
I like it. And
Yeah.
I'm gonna ask, Ron, should we speed it up, because time is running out?
yeah, time is running out. What I wanted to do just by showing this table was my thought process was basically to continue with columns E and F. Right, so let's consider die to die, and let's consider, you know, XPU to XPU. Basically focus on these two columns, because those are certainly different use cases, or I would say maybe in use cases, different technologies, right? On die to die versus non-die to die. Is there any objection to that?
Well,
Just to
at a system level, again, I don't know if we stop at XPU to XPU, we're missing switches that are in between.
Yeah, my issue is that XPU to XPU in practice often involves a switch. I mean, the traffic is still intended XPU to, the application is XPU to XPU, but the implementation may have a switch. So do we include that or not?
Okay,
I think we should.
We
I
can
think
revise it and
Yeah.
just, you know, leave out the, just say die to die versus non.
Do we want to include the die to die, or is like
The position of a switch is important because the
Mhm.
technology and companies are different from XPU companies.
Well,
So die to die is of course important for maybe not sure.
no, say, do we actually look at like
but if we take a
GPU to
step,
memory type of interface at this white paper or not?
If you look at it, it only affects bandwidth density. That's
But if we-
really the only parameter that is unique between
Not-
the two. So maybe we can collapse it further to just one list
Well,
of requirements.
Radix.
No,
yeah,
radix is
I think Radix is important too, but the thing I was gonna say is I think we're going the wrong way a little bit. I think this table in and of itself is not terrible. I think you know, we need to just consider from the end user's point of view. And so the end user, what are they doing, right? So they're building switches, they're building compute, they're, you know, mostly clusterized. They're using parallelism, and this parallelism requires network throughputs and things like that. And they're all interconnected into a system that achieves the result. So I think that I would just mildly reframe this, Ron. I wouldn't dramatically kill it and change it too much. I would because again, you know, just let's step on the other side of the aisle and say, I'm a buyer. I want to buy a system. What do I need to know? Like what are the questions that I would have, you know, as
Yep.
far
from the topology diagrams for making all those large clusters work. You guys know, first is the die to die, then is the chip to chip. What is the other chip? A lot of times it is a switch, and then after a switch there might be yet another switch, and the requirements is connectivity versus bandwidth or throughput, fat pipes versus very many little things. Very many little things reduce the number of switches we might have. If a particular port can bifurcate many times, then I can get rid of a layer of switches. But then going from switch to switch, it makes sense for it to be fat pipe. So everything be aggregated again, not we don't need anyway. So therefore, every one of those is important from die to die, from chip to chip, and then we have to describe what these chips are. GPU to GPU direct, yes. GPU to switch, yes. Switch to switch, yes. Every one of them might be different because of the radius, because the company is doing it, and because of the packaging technology for doing that.
Okay. All right, Bobby, it looks like we are just about out of time. Maybe we can continue this discussion next week, but we do need help filling out some of these parameters. I think if we focus on, I guess what I've listed in blue here, as sort of our homework assignments. Maybe this helps to bound the problem.
So
I
I
also
definitely
want to
can
throw
help
in-
with the structure, but you guys are the experts for the individual parameters. But
Hey, Ron, I also want to throw in, when I reformatted the rest of it, the next section is analysis. And then the last section is SROI requirements. And, you know, so consider that with the table, I guess, is all I'm trying to say.
Okay, so back to the next section. Oh yeah, there we go.
But before I drop, I just wanted to mention, I put my draft with a lot of my thoughts and issues on the shared drive in the interest of time, so that, you know.
Great.
Okay, thanks, Karen.
Yeah. Thanks, Karen.
Take a look at it. All right, appreciate everyone's time.
Sorry, we ran out of time. I talked a lot.
Yeah,
It's good. It's good. Love the discussion. So yeah, we'll continue this. And in the meantime, if you have any thoughts, any things, please pop up and shoot me emails or anything. We'll go from there.
Thanks,
All right.
everyone.
Thanks.
Thank you,
Yeah,
everyone.
thanks.
Yep.
thank you.
Good talk. Bye.